Okay, for this video, we're going to look at equations of lines. We're first going to see how the slope-intercept form is represented and how we can prove that by using the slope formula. So here I've written out m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we're given a couple of points to fill in there. And then I'll show you how we can manipulate that. We can solve out for y in terms of all the other stuff, just doing a literal equation like we've done in the past, but it's a little bit more complicated. So I'm going to pause the video and fill in. I'm just going to write in these values and go from there. Okay, so I'm going to do this off to the right, and I have m equals y sub 2, I've labeled as the y, minus y sub 1, which is b, all divided by x sub 2, which is x, minus x sub 1, which is 0. And now I'm going to solve for y. One thing I'm going to do is just take out this minus 0 because we don't need to write that. And I need to clear my denominator first, so I'm going to multiply both sides by x here. Remember, my goal is to get y by itself. So then I end up with xm, or I'm going to say m times x, equals y minus b. And then add b to both sides. And again, remember that these are not like terms. The mx plus b I just have to write out. Equals y. And we like our variable we solve for to the left, so we're just going to write it out as y equals mx plus b. So you may not have ever seen how that relates before, but this is called slope-intercept form because we clearly have our slope. We've labeled that here as m. We know that that's the change in y over change in x's. So that ends up being the coefficient of the x when we have it in this form stripped down to just solving for y in terms of all the other stuff. And b is only when x is 0, as you can see here. We can even put this little, that was originally a minus 0, remember? So that's it for that part. We can also prove out a different form. It's called point slope form, but we'll do that one a little bit later. We want to call this one is slope intercept because we specifically have the slope and the y-intercept. When we don't, we'll use point slope form. So now we can use that and find the equation. We can write equations of a line if we have the slope and we have the y-intercept. Again, we'll be able to figure that out when we have a different point, but for now, we're just going to use these 2 points. So I have, again, just to label some stuff here, this y is my input, my output. The x is my input. The m is my slope, which is rate of change in y over change in x. There. And then the b is my y-intercept when it's the y value when x is 0. And only when x is 0. So here I have my y-intercept. And that would be b, because this we call 0b. And so that's just the 5. When we write it as a point, which I often like you to do, we include the 0, but in this case, because we're plugging into this form, y equals mx plus b, we are just going to want to put the 5. Now the other thing we have is the m. Okay, so we know that m is -4/3. So we just leave the y. So we have to figure out what our output is based on this information. So we have -4/3 goes in for m. Just leave it as an improper fraction is good. We don't want to write mixed numbers or decimals in general, especially not decimals if they do not terminate, because then we'll have rounding error. And then the b is 5. Okay, so now our function or our rule is y equals -4/3 x plus 5. So that's the rule for a specific line that has this specific slope and passes through that y-intercept. It will pass through other points as well. We can also draw the line from that information. We could quick sketch it out, and because this probably is review for most of you, I'm going to show you how that might look just really quickly. So I'm just sketching here. So I would have my y-intercept, so it's 1, 2, 3, 4, 5 right here. And then my slope tells me to go down 4, 1, 2, 3, 4, and over 3. So about there. And then I could do it again and again, but I'm just sketching here. So this would be what this line looks like. Just roughly. So I don't have graph paper, just doing a rough sketch. I know it's descending from left to right, so I got the negative slope correctly. I actually should put my negative here a little bit more centered. There we go. And then I have my y-intercept. That tells me a lot of information right there. So if this were a word problem, I'd say about money, losing money, or something's depreciating. It started at $5, say, and then I lost I lost 4/3 of a dollar. Or you could say 1 1/3 dollars every day, for instance, something like that. So now we're going to go on to the next one and then see if we can look at a graph and find the equation and write it in slope-intercept form. And after this one, I'm going to stop this video and do another part. I'm trying to keep them short to just a few examples, a couple or a few. Find the equation of the line in slope-intercept form. So first thing we have to kind of figure out is what our y-intercept is. First, I might want to write y equals mx plus b, just so I'm tracking what I'm doing. And then the b, I can clearly see right there is 0, 2. So my b, therefore, b equals 2. And then the other thing I want to figure out, I'll get this out of the way here, is my slope. So I can go up. Let me see where it hits on a corner. It's the best thing to use. So I'm going to say that one's clearly on a corner. So with these, you are doing some form of estimation at times. So I go up 1 unit and right 2. So plus 2 is my change in y, and my change in x is also plus 2. So remember, slope equals change in y, always in the top, over change in x. So I have, oops, sorry, this one it should say 1. Said 1, but wrote that. 1 unit is plus 1. And then we have 1 over 2. So now we're going to plug that all in over here. So the y just stays. We're just doing the, we don't know the output yet. We're figuring out the rule. And then we have a half x plus 2. And that's our rule. And we could check this. We can check to see if there's a point that falls on there. So if I have negative 2, 1, that's the point negative 2, 1. Let's see if that actually falls on that line. So if I plug in 1 for y, half times negative 2, and then add 2. Are these two things equal to each other? Let's verify. So that reduces to negative 1, and I would get 1 equals negative 1 plus 2. Or does it equal? Yes, in fact it does. So this is how I verify or check to see if that is correct by plugging in a point on that line and seeing if it fits. So that's it for this video. Thank you for watching.